Welcome everyone to the second of our talks this semester. So I'm Darius. I'm a joint computing and physics student, and today I'll be taking you through two basic but very important concepts in programming in general, and also in Python, which is data types and control structures. In Python, and again, programming languages in general, variables and expressions are assigned data types. These data types do a number of things. First, they allow the compiler to understand what's going on, because in memory, all your data is basically a string of zeros and ones. Your program doesn't really know how to read the zeros and ones unless you tell it how to do that. Because, for example, the string 0, 1, depending on data type, can mean a lot of different things. It can mean the integer 1. It can mean some character, which I forget what the Unicode for that is. And floating point, I'm not even sure it's a valid number. But so you need to tell the program how to understand variables. So in Python, you give variables values by using the summon operator, which is the 1 equal sign, which is pretty standard in programming. So Python is what is called a dynamically typed language. I won't really get into the nitty-gritty of what dynamically or statically typed languages are, but what you need to know for Python in particular is that you don't actually need to tell your Python program what the type of any given value is. It'll infer that automatically. So for example, here you're assigning the integer 42 to this variable. This is an integer. Python will know it's an integer, and you don't need to tell your program anything else for it to know that it's an integer. So there are, so here are some more assignments. And we see some operations with variable names. So in Python, variable names are essentially, as demonstrated here, are just tags for the values. What you're always working with are values like integer 21 or the integer 14. But to make it easier on yourself, and so that you can reuse previous values without having to rewrite them every single time, you can assign them tags like A or B or answer. Your actual values will be living somewhere in memory. You don't actually care where they are exactly. You don't need to know that. But the tags will essentially tell the program where to look. And the program will look the location tagged by, say, A, and it will see that that refers to 21. Now, there are lots of different data types in Python. You can make your own data types. We won't be getting into that here. So these are some of the more common types you will see when you're doing anything in Python. So another use for data types, and why we have different data types in the first place, besides knowing how to interpret memory, is some operations are only valid with some particular data types. So we'll see a little bit of this later, but for example, while adding two integers together using the plus operator is well defined, you just add two integers together and you get what you expect out of that. Trying in Python to add integer to a string will give you a runtime error, which is Python telling you that you can't do that because it's not a defined operation. So that is one of the main reasons to have data types in programming, is so that you can more easily reason about what is allowed and what is not allowed in your programs. Booleans can have two values. They can be either true or false. They represent logical conditionals. You'll be using Booleans a lot, and you'll see some uses for Booleans in a bit when we start talking about loops. I have integers, which is one of the primary numeric types. Integers act pretty much the way you would expect an integer to act from mathematics. Integers in Python can represent pretty large values. I don't actually remember the official range, but most integers you can think of you can represent as an integer type. You can subtract them, you can add them, you can multiply, divide, exponentiate, pretty much all the operations that you would expect an integer to have. Floating points, another numeric type. Basically, these are the two numeric types you'll be using when you're writing Python. Now, floating points are a bit trickier. In theory, they represent real numbers. So pretty much any fraction you could write as shown there. And that's all good and fine. In practice, implementing floating point is quite difficult. You can really dedicate a whole lecture or two onto how to implement floating points, so I won't really get into all the details. You can feel free to look them up afterwards if you like. But what you do need to know is that you need to be very careful of how you use floating points. Floating points can easily break some of the properties you would expect numbers like these to have. So, for example, floating points are not always commutative, which you would expect from real numbers. So a plus b is not always equal to b plus a when you're doing floating point arithmetic. And these sort of things can be quite trivial. But in bigger programs, when you're dealing with lots and lots of floating point numbers, some of them possibly quite large or quite small, that can lead to some real bugs. And again, we have most of the usual operations defined in them you would expect, addition, subtraction, etc. So now we have strings. Strings represent text. In Python, they are a primitive data type, which is a bit different than how they're handled in a lot of other programming languages. You can do a lot of things to strings, as again we'll see later on in the interactive part of the lecture. You can index into a string to find individual characters. You can concatenate two strings together using the plus operator. Python even has a weird thing where multiplication is defined on strings. So if you multiply a string by 2, let's say, it will repeat the string twice. Now lists. Lists are probably one of the main data structures you will ever see in Python. They are what you use whenever you need to hold a collection of elements, because that's essentially what a list is. You put some stuff in a list and it sits there. It can be of any type. So there we see a list of integers. There you see a list of strings. You can combine and mix types, so you can have a list that contains some integers and some strings, and even other lists in itself. Each element in a list is assigned a position, starting from 0. Python always starts indexing from 0, which is, don't confuse that with something like MATLAB, which starts from 1. Yeah, you can index into lists as with strings using the bracket notation, which you'll see again later, by going from 0 to n minus 1, where n is the length of the list. The lists have a lot of default functions defined in them, which we may not go into this lecture. But you can do things like find whether a value is in a list, find the max value of a list, concatenate two lists together, etc. And you can, of course, loop over lists, which we'll see in a bit. Lists are it's a very diverse data structure. You can use it for a lot of things, and you will use it for a lot of things. If you actually start writing Python, it's important to get to grips with how lists work exactly. And then we have dictionaries, which is the other main data structure you will see in Python. So dictionaries are a bit different. As the name implies, dictionaries contain keys and values. They map keys to values. So, for example, we see here in the first dictionary example, we've mapped Henry to 170 and Sarah to 160. This has a lot of uses. So you could actually make a dictionary using a Python dictionary. So you could have words that are keys and have values that are the definitions of the words. You can then index into a dictionary by using the keys. So, for example, if you index into the first dictionary using the key Henry, you'll get back the value 170. Dictionaries are used for a lot of things. They are used a lot in web services, for example. They are used for handling pretty much whenever you want to associate some value to another value, you use dictionaries. So there's also subtleties with dictionaries, which I won't go into here because you really should just read documentation about it. Namely, there are some restrictions with what values can be keys. Not all values can be keys. For example, you can't have a list as a key. Python will not allow you to do that. Pretty much that's the basic idea of dictionaries. We also might see them referred to as maps or hash maps in some other places because that's what our programming languages call them. So that's a very quick run over of data types in Python. There are, of course, others that I have not mentioned, but those are by far the most common ones that you will be using pretty much whatever you do.